In today's class, we will be looking at electric flux. So, and the easiest way to explain what electric flux is think of electric field lines that are penetrating or crossing over a particular area. So, electric flux is a measure of the number of electric field lines to cross a given area. So, we can explain this way. So for an area that looks like this, electric flux is the amount of field lines that are able to penetrate through. For example, these particular points are not able to penetrate through it, right? So these are not electric flux. They are not included in the calculation, but we only consider the ones that are penetrating through this surface area. So you might be asking, why do we even measure this? So electric flux are important to measure the strength of our electric field. So if our electric field is strong, then the flux will be higher as well. Or if the flux is higher, then we know that the electric field is really strong. The symbol of flux is like this. And to calculate flux, all we need is the electric field, strength, and also the area. So the electric field could be defined as the region around a charged particle in which it's able to exert a force. So to calculate electric field strength, we follow the formula E equals force over Q. So in this case, force is electric field force. So as you know, we actually talked about this in our last video, but if you don't remember, we can calculate this using the formula QQ over R squared. So Q1 and Q2, and then this is gonna be our constant. And then we have the distance between those 2 points. But when we plug everything, and we can have it will look something like this. So when we simplify KQQ over R squared Q, then we will get Q will be cancelled by Q, and then we get KQ over R squared. So in this case, this is the test charge or the source charge, and then this is the constant of proportionality, and this is the distance between 2 points. So first you will need to calculate the electric field strength, and then this is the area, which can be found by just multiplying. If you're given like in this form, you can just multiply it, or you're just going to be given the area itself. So yeah, that's pretty much it. But this only works if the electric field lines are perpendicular to the surface. So for example, if this is our, I'm not really good at drawing, guys, but bear with me. If this is our body, then if these are the electric field lines, when they cross over, if they make a 90 degree with the surface, then it is said to be, we can use this formula. But if they have an angle just like this, then we use the formula flux is equal to EA cos theta, in which theta is just like the angle formed between the surface that is being penetrated and the electric field line. But what if we're given electric field and the area as a vector form? So in this case, we'll just use the dot product of E dot A. We will be seeing this in an example, but just try to remember that. So what can we say about the area vector? So the area vector could tell us a lot about the flux. So the area vector, if it's on a flat surface, then it has the following properties. Then the first one is the magnitude is equal to the area of the surface. So to find the magnitude of the area vector, then all we need to do is find the magnitude of the area of the surface, which is just multiplying the two numbers if we're given both. And then the direction will be along the normal or perpendicular to the vector. So as you can see, if it's on a flat surface, then it will be in the direction or perpendicular to the surface. So just take a moment to do this example. A 2 centimeter by 2 centimeter square lies in the xy plane. Find the electric flux through the square for the electric field vector E equals 50 K plus 20 Newton per coulomb. Take a moment, pause the video, and try out this problem. So when we solve this, first thing that we need to know is just understand what's given. So as you can see, this 2 centimeter by 2 centimeter square is in the xy plane, meaning that it is perpendicular to the K plane or axis. So when we multiply this, or this dot product will just provide us with the K axis. And then when we look at what we're given, electric field strength is 50 JK plus 20J. So like we used in the vector form, you just need to find the dot product. If you haven't, please watch or check out my dot product video. It's really good. It will explain everything what I'm doing here. But this K will be multiplied by this K, so 50 times 8. Y'all, and by the way, this is in centimeter, guys. I forgot to explain this, but this centimeter needs to be turned into meters, so it's just gonna be 4 times 10 to the power of minus 4 meter. And then it won't have a significant effect, but it will have a very huge number difference. So I won't answer I won't change the answer, but like the calculation has to be right, obviously. So 50 times 4 is going to be 200 times 10 to the power of minus 4, and then this J cannot multiply with anything because this area has no J value, so it's just going to be 0. So just simplifying everything, we get 0.02 Newton meter square per coulomb. So please don't forget this. The SI unit of electric flux. And yeah, that's pretty much it, guys.